Hello, concrete revolutionaries, and welcome to another episode of Building Better with AI. I'm your host, Sarah McGuire, and today I'm excited to be discussing a topic, our first topic that was suggested by a listener, tackling constructability when optimizing concrete mixes. Today, I am joined by two concrete experts in this field. Cary Kopczynski is the CEO of CKC, an acclaimed structural engineering firm with offices in Seattle and Chicago. He previously served as the president of the American Concrete Institute and is currently the chairman of the board for ACI Pro, an ACI Center of Excellence. Cary has also been honored with the OPAL Award for Outstanding Leadership by the American Society of Civil Engineers. Alana Guzzetta holds both a bachelor's and master's degree in civil engineering and is the National Research Lab Manager at Vulcan Materials out of the Bay Area, where she leads all their R&D initiatives. With over 15 years experience, Alana collaborates with key stakeholders to advance sustainability in concrete specifications that meet performance goals and reduce embodied carbon. Alana and Cary, welcome to the podcast.
Thank you, Sarah. Glad to be here.
Thank you so much.
So the reason this topic was brought to us and why we were really excited to talk about it with both of you is that as Geotech has been on this mission to try and optimize as much as we possibly can in concrete mixtures, one of the biggest challenges that we've actually had is not necessarily having the data that ties in well to helping people output mixes that are constructible. And that's a big topic that we want to talk about with both of you coming from such a diverse background and dealing with these issues in a real world and also at the educational and the standardization level. So first, I would really love to just start by having you guys introduce yourselves to the listeners, maybe starting with Cary. Can you introduce yourself, a bit of your background, and why this topic is near and dear to you?
Well, I come from a construction family. I became interested in civil engineering many, many years ago. My father was a general contractor, and I grew up immersed in the world of construction. Worked in the summertime as a construction laborer in high school and college, which was very, very valuable and good experience. And then after graduating college, decided to open my own firm, which I did. I worked for a couple of other firms, local firms here in Seattle prior to that, but I opened my own firm and I've been in business about 35 years. It's been very, very interesting, and I'm very pleased to be here today talking about constructability, which is a topic near and dear to my heart.
Thank you so much. We're excited to get all of your insights on this. And Alana, can you share a little bit about your background and why you decided to pursue a role in this, and also not just in the field of construction, but also really pursuing the changing of standards and how we're looking at concrete mixtures today?
Well, yeah, my involvement in the concrete materials side wasn't anything that I had vision for. It was something that I got involved in because there were different circumstances where that worked out well. And I just ended up really enjoying it and staying with it. When I went to college at San Jose State, I participated in concrete canoe primarily because I was looking to make friends and have community, and ended up really finding it very interesting, the mix design process and the teamwork involved in all of that. And then because of that background, when I graduated with my bachelor's degree, I was still very interested in structural engineering. And at the time in 2011, most structural companies weren't hiring many people. And if they were really looking for people with master's degrees. So that's where I ended up taking the role in the research lab. It was a great location in San Jose, close to the university. So I could be doing grad school at the same time for the first 3 years working here. I was also able to work under a licensed engineer and get the hours that I needed towards my professional engineering license. And then ultimately at the end of getting my master's degree, I, had 3 years of experience here and just really enjoyed the team and the culture. And I've always really liked the material science part of it, those classes in school, but didn't have any kind of vision for a career opportunity that way. So this ended up just being a really unique position. And with being in the research lab, I found it really interesting to get to check out the new materials and the new products, and then try to figure out, well, how do we look at this in a way that is practical? And how do we provide practical data and information to our quality teams who then end up implementing it out in the field? So I've just enjoyed it and stuck with it.
Amazing. And Cary and Alana, you two know each other well, I assume. Have you worked together on projects in the past?
We have worked together.
Yeah.
Are you able to share on what?
Well, we, as you mentioned, Sarah, we're based here in Seattle. We have an office in Chicago as well, CKC, but we do a lot of work in the Bay Area. And so we have crossed paths with Alana on some of our projects in San Jose and Oakland, other parts of the Bay Area over the last, I would say, 7 or 8 years, I think, Alana, something like that.
Yeah.
Pre-COVID.
Yes, exactly. I was thinking about one project that comes to mind this morning was the 1900 Broadway project in Oakland. And that was one that I didn't have a lot of personal involvement with, but, Central Concrete and CKC and our customer Pacific Structures. That one I think is an interesting example of constructability because we did utilize both Geotech Smart Rock sensors, also the Verify system on our trucks that monitors temperature and slump. And that had a unique, mix that was required as well with steel fibers in it that's through, CKC's design.
Right. That was actually a very interesting project, probably one of the more interesting that we've done in the Bay Area. It's a 40-story tower in Oakland, and Alana and her team were very helpful because we did use a steel fibrous concrete mix for the shear wall link beams, and those mixes are very tricky. They're very sensitive to all sorts of things when they're being batched, but they're very, very critical to the performance of the building. So we were very pleased to have the input of Alana and people at Central.
Amazing. So on that topic, as we kind of talk about constructability, because we have listeners coming from all facets of the industry, would one of you take a shot at defining exactly what is constructability and why is it so challenging in today's concrete mixture world?
I'll take a shot at that. I think constructability is something that's been talked about since, as long as I've been in this industry, it's been talked about, and it's given, I think in general, more lip service than actual focused effort. But the definition of constructability that we use at Pro and at ACI is construction input during design. So the basic idea is that while a design office is designing a building, they're receiving valuable input from the people who are going to build the building. So they're receiving input from material suppliers. They're receiving input from subcontractors. They're getting input from the general contractor. And the idea is that because of that valuable input, the design they produce, when it's finished, is much more amenable to productive and efficient construction system. As contrasted to too often what happens where a design office is hired to design a building, or it could be a bridge, it could be anything in the built environment, but a design office gets hired to design something, and they go away and they do their thing, and they turn out a roll of drawings, and the contractors pick it up and say, wow, if only we had been able to provide some input along the way, we could have created a much more efficient, productive, and effective system. So the essence of constructability is that designers collaborate with builders while they're designing, and they incorporate that input into their design process.
Yeah, I think that's great. That's something that has been a part of my role, really, is being able to get in early on that collaboration and work with designers, because the, supplier is usually selected by the contractor, after the design has been completed. And so having the opportunity to work with designers ahead of time or work with project teams ahead of time to show what we can do with concrete mixes and what type of material performance we can offer that may even impact what an engineer can do on the structural side is an aspect of my role that has grown that I really enjoy. And I think too, from my perspective in the research lab and on the materials side with constructability, it's also for us the very practical part of how to put all these ingredients together and mix them on a large scale. Because it's pretty easy for me to take 15 buckets of different materials, try something new, put it all together in the lab. But then it's a whole nother thing to figure out, well, how would we actually transport all 15 of those products at scale? Where do we store them at the plant? How would we actually get them mixed? And so that's a part that I have to think of too in evaluating new materials, is looking at, well, not only what do they do in a mix and what are the right proportions, but then working with the team to figure out how can we actually do this at scale, batch it, deliver it. And then for the contractor, it's how do we take the concrete, from the truck and get it in place properly, to meet the intention of the design.
Perfect. And so that perfectly summarizes as well how you two have been a perfect, pair to bring onto this episode to talk about this subject, because the collaboration that the two of you have had already in accomplishing this is, I think, something that is not happening enough in the industry. And Cary, I want to put it back to you because you said that there's a lot of lip service around this topic, but it's not really happening in practice. And I think that's the common thing that we hear from our customers, is that they often get specifications or mixed design prescriptions from the engineering firm or from the customer, and then they don't have a lot of ability to adjust from there and actually work collaboratively as a team. And Cary, I'm curious to know, as somebody who your role is really focused on making sure that that does happen, why do you think that that's not happening enough throughout the rest of the industry today?
Well, that's a very good question. I think a couple of reasons. One is in the traditional design bid build method of project delivery, which is commonly used by public agencies and a lot of private firms as well. There's really no opportunity when you're designing to contact the people who are going to build the building because you typically don't know who they are. So while you're making very important design decisions, even though you'd love to have the input of the material supplier, people like Alana, you'd love to have the input of the concrete subcontractor, you'd love input from the guy providing the formwork. You don't know who those people are. And so consequently, you do your best, you make the decisions you think are appropriate, and you deliver the design and then realize later that, once the team is selected and you begin to create a working relationship with that team, you realize that you could have done things differently. So that's one big reason I think is the traditional project delivery method of design, bid, build doesn't encourage collaboration. The other reason in the projects where you do have a pre-selected team, and actually in the private market, at least in the projects that we work on, which are typically urban buildings, it's becoming more common to pre-select the construction team at about the same point in time that the design team is selected. And I think a lot of smart owners have become conscious of how important that is and aware of how important it is, which is why they're doing that. But even in those situations, I think too often they're not encouraged to make that contact with the people who are going to be outfield building the build. Part of it is that you're always under schedule pressure. So, you're fighting a fee that typically has a pretty tight limit. By the time you get into construction documents, you get through schematic design and design development, you get into construction documents, oftentimes your fee is running out. So everybody is trying to wrap up the design quickly, get it out the door and move on to the next project. So about the time that you would really need and welcome that input from the construction team, you're out of time. So that's the other thing. I think so much of what we're doing with Pro, I know, which we'll talk about here a little later, but with this new ACI initiative, so much of what we're doing is trying to create an attitudinal change on the part of design. So the designers, they view constructability as part of their obligation. And I think when we do accomplish that, we're making progress. I think when design offices begin to view constructability as part of their obligation to the project and the client, good things will happen.
Yeah. And that's a perfect segue into the question that I want to ask Alana now is that, Alana, in your role, unlike so many other companies across the country that are not finding the time to prioritize this is like your main bread and butter. This is what you do on a regular basis is you're getting out there and you're advocating for that. So how are you doing that differently at Central and at Vulcan Materials in the Bay Area to get that mandate out there and tackling this issue of there's a lack of incentivization for people to actually collaborate? How are you getting out there and doing that? And how would you recommend that other companies do that from across the country that aren't finding the time to do that today?
Yeah, I think we make ourselves available as a technical resource. And, we do have a pretty unique technical team here in the San Francisco Bay Area specifically because our quality assurance teams have their own labs. And then my lab is the one that's specific to being on the research side. So we are not responsible for some of the day-to-day projects going out and day-to-day production. We've got time set aside for the research side for looking at new materials. And that does give me some of the flexibility then with my time also to do these collaborations. We also have a sustainability manager as well, who's got a civil engineering background here in the Bay Area. And so that makes for a very well-rounded technical team that allows us to be kind of bridging the gap between the field and then on the design side, being able to just be there as a technical resource. I think involvement in industry organizations as well, like ACI, like the Carbon Leadership Forum, which Central Concrete was a founding member of. Places like that are also great ways to connect and sort of just share, here's on the technical side, what we can do and what we can offer. And then sometimes we'll have people on projects who will reach out to us ahead of time and we get to talk a little more specifically related to that project or really bring that. And I've also had contractors and people from the industry ask well, what would you see as sort of an ideal bid process? How could we get input a little better? And I don't know that I've got the perfect solution to that, but at least having those conversations is showing that there is interest in trying to figure out how do we best collaborate up front.
That's amazing. And both of your organizations, your thought leaders, your first movers in a lot of these new initiatives that are going out there, you're very involved. I mean, Cary, of course, you played a pivotal role in many ACI initiatives, including the one we're going to talk about shortly. But I'm curious to know from either of you, for the average company out there, why should they care about constructability? constructability in today's world when we're dealing with such heavy time constraints and it's just about getting things out the door? Why should this be something that's top of mind for them?
Well, I have a couple of answers for that, Sarah. I'll go ahead and start that conversation. I think one of the big reasons to care, the McKinsey Global Institute did a deep dive into the construction industry back in 2017. They've done a number of studies on construction, but there was one in particular in 2017 where they evaluated productivity trends in the construction industry. And construction being defined as everything from material supply all the way through to putting the last shingle on the roof. It was material supply, it was design, it was field fabricators, the whole gamut of construction activity. And what McKinsey concluded is that the inflation-adjusted productivity improvements in construction have pretty much been nil since 1947.
Wow.
And shortly after World War II, if you look at inflation-adjusted productivity trends in our industry, there's been almost no improvement. You contrast that to industry in general, where there's been a 300 to 400% improvement in productivity. And they define productivity, by the way, as the value created per unit of time. So how much value does one worker create per hour, let's say? That's the definition of productivity. So the reason to care is that as an industry, we're not getting our gears to mesh very well. We have too many friction points. We're too fractured. You know, building a big project like one that Alana mentioned, 1900 Broadway in Oakland, the 40-story tower that is just about ready to open up, by the way. So if you want a very nice apartment, there's going to be one available in downtown Oakland. But that project is a good example because there were hundreds of different material suppliers, fabricators, design consultants, subcontract involved. And that's common. When you build a big building, you have hundreds of different companies involved. Everybody builds their little silo. They build their moat around their respective piece of the responsibility. And that's what they primarily care about. Very seldom does the entire team care about delivering a good project on time and on budget. Even though I think subconsciously we all know that that's where we're trying to head. We're trying to build a good building on time and on budget. What people primarily care about is their little piece of it.
I think that's an incredible answer because first of all, we will go looking for that report and link it in this podcast description so that people can read it themselves. Because for us to have not advanced since 2 years after my father was born is really hard for me to get my head around. But we are in an industry right now where we are being asked to do a lot more with a lot less people, a lot less time, a lot higher demands on cycles to open roadways and strip forms and everything. Everything is going up. And yet we're facing so much pressure to also get leaner, become environmentally sustainable. And when we have all of these people working in their pods, like you said, they're focused on budget, but they're focused on their budget. They're not focused on, what if one pocket can spend more to increase the efficiency of the 4 other pockets of all of the other trades that need to come in and actually help that. And so there's not enough focus on people looking at this holistically. And eventually something's going to crack the more that we're asked to do more with less. So I think that's really fascinating. Alana, did you want to add anything to why we should care about constructability?
I mean, I think Cary covered it really well. And that was super interesting as well, thinking about it just from the perspective of not even just the concrete portion, but how everyone, works as a team and has ownership in the entire project. I think also why we care is just that, it makes everyone's lives a little easier. If no one loves handling problems or things that are not going well or things that are not being placed well, at the end of the day, everyone who's in the field and working with the material, working with the product, delivering it, placing it, if it's going smoothly, it just makes for a much nicer workday. And I think too, just in, delivering something to the owner that works well and thinking about, concrete as a building material, I think it's such a great material. It has such great benefits, such great versatility. And so I love to see it continue to be, a building material of choice. And, for that to be the case, it needs to be something where constructability is going well and going smoothly.
That's fair. That's very fair. So I think, Cary, earlier you highlighted something as well that's really interesting is that the way that the process is set up today to have everybody collaborating doesn't necessarily work as well. And by the end of a project, we may have been able to see some places where we could have made improvements, but then we're already on to the next job. Do you see any sort of post-mortems that are happening in the industry today when a job faces issues with constructability along the way and then tries to learn from that for the next? Or are we seeing a gap in that knowledge transfer? or?
No, I think there are some very positive things happening. I think we want to focus on the fact that as an industry, we do need to improve in terms of constructability and collaboration. But we don't want to overlook the fact that we are making gain, and we are, I think, improving in the knowledge transfer that you just referred to. I think people, at least in my experience, are becoming much more aware of the need to talk about efficiency and constructability early in the process instead of waiting until the design is done. I know that when my career started, value engineering was thought of as what you do when the design is complete. You then sit down and you go through and you do a big plan check and you value engineer and you try to make changes that would move the needle on cost and schedule. I think now value engineering is thought of as something you do early. So you value engineer starting in the schematic design phase. So I think there is the attitudinal change that I mentioned earlier, which I think is so critical to improving constructability. I think it is happening. And I think the postmortems that you asked about, Sarah, in my experience are becoming more common, where you finish a design and either at the conclusion of design or sometimes at the conclusion of construction, you sit down and debrief. You get the team together and you spend a few hours over lunch or whatever and just talk about what worked and what didn't work. How can we improve on the next building? How can we make the next one better? So I think there are some real positive trends.
And Cary, in doing what you've been doing for 35 years, as you said, and also because you've been in the practice yourself, but you're also doing a lot of consulting now, so you have so much visibility into what's happening. Can you elaborate on maybe any topics that relate to quality, constructability, that have improved over the last 35 years, and maybe tipping points that you saw, certain things that really needed to happen, or ways that knowledge needed to transfer among people that is actually making that difference?
Yeah, I can offer a couple of examples there. One has to do with ready-mix concrete, a big one, ready-mix concrete. When I started my career, high-strength concrete was anything over about 5,000 PSI. If you went to 6,000, that was, oh my goodness, that's ultra-high strength. And if you talked about going higher than 6,000, people would have apoplexy. Fast forward to today, and we are commonly in Seattle now using 12,000 PSI. We've done a couple of buildings with 15,000 PSI, where we had a specified strength of 15,000 PSI at 90 days. So, going from then until now, there's been a dramatic improvement in our understanding of the way concrete behaves. There's been a dramatic improvement in the ability of people like Alana and others to design these ultra high performance mixes. And I think there's also been a recognition by designers that when you're going to specify a mix like 10,000 or 12,000 or 15,000 PSI, you need to have these conversations early. You need to be talking to your network of people, even if you don't know who the supplier is, which oftentimes you don't until you've actually sent the specs out. But you need to have a network of people you can consult with and get input from so that you don't create some crazy specification that the industry runs away from. Or the other thing that we're seeing, another example, and I think this is now changing in a positive direction as well. A number of years ago, maybe 8 or 10 now, 12, I think a lot more design offices started specifying elastic modulus. So they would specify strength and they would specify shrink, or whatever else they thought they might need, but they would also specify elastic modulus. And there was a dramatic difference in the way different firms approached the specification of elastic modulus. We saw a few that I'm not sure how the market could even respond to, where there'd be an elastic modulus specified and there'd be a plus or minus 5% limit, something like that on the specified number. You fast forward to today, I think that's gotten better as well because ACI has sponsored a number of symposiums and various presentations and so forth at the conventions that talk about elastic modulus and the way it should be specified. And creating the dialogue between the specifiers and the suppliers has been very beneficial. So again, good things are happening. I think constructability is a really important topic for all of us, and I'm thrilled to be part of this today because it's near and dear to my heart. But again, we don't want to obsess over the problems. I think we want to stay focused on the fact that we are moving the needle in a positive direction.
That's great to hear. And Alana, I want to pivot it back to you as well and just ask, in your role with pushing the importance of this, I'm sure you've had a lot of people that have also just said, I don't have time for this. I'm not interested in pursuing this. I've got other things to do, and they just don't prioritize it. So for the person that might be listening to this thinking, I'm in Alana's shoes right now, I'm trying to have that conversation and no one's listening to me, what would you advise that they lead with to state the importance of this before they're sitting in there and doing that postmortem and having to use it for the next job?
Something that comes to mind is really thinking about understanding the priorities and sort of the businesses of others within a project. And so I think about like our customer, we'll have our customer, either the contractor or the subcontractor, come for tours of our plant. That way they can see what goes into day-to-day production. And, sometimes we don't have confirmation of some of our day's orders until the day before. And, that impacts how many drivers do we need to have? How many trucks do we need to have? What types of materials do we need to have? Are we using more slag that day, more fly ash that day? And because the plant is not going to hold enough material for the entire day's production. So we're coordinating material delivery, things like that. On the flip side, it's important for us to understand what kind of pressures is our customer under and why sometimes do we not have that order finalized until the day before? What pressures do they have? And I think with that, then you figure out, well, how do I bring value to the other people on this project, whether it's our customer, whether it's the general contractor or the designer? What are the value points for them? What are the stress points for them? And what role do I play in helping with that?
And so now I really want to pivot this into the concept of technology. And I'm curious to know from both of you maybe how the different technologies that you've been using throughout the years to also prove this or demonstrate this or continue to test for these things. Especially, in this industry, data is powerful, but translating that data into information and actual fact that we can actually use to prove ourselves. So Alana, when you're going in and having those conversations, the ability to pull the necessary data that you need to, prove to people that this is worth their time or this will get us to a better answer because I have that. But I also know that in this industry, bringing that data together can be a real challenge. And that's something that our customers definitely experience, especially with the evolution of technology. It's great that we have all of this data, but bringing it together in one place to actually use it quickly when we need it, when we're encountering those opportunities to make change. I'd love to get both of your experiences with how technology has grown, but also where you might be seeing a gap in technology being able to help these conversations today.
Yeah, I'll go ahead and offer a few comments there. Back to what I was saying earlier about the fact that for a lot of projects, people get siloed and they work more or less in a vacuum. So they do whatever it is they're doing on the project, whether it's engineering or fabricating components or whatever it might be, and they're working in a silo. And the silo applies not only to physical issues, people and materials, but also to information. And so information can become siloed just like people and things can become siloed. And so I think if you look at what's happening now with AI, for example, and all the things that AI is bringing with it, I think we're pulling information out of those silos and we're making it more readily available to other people. So the work that Central Concrete is doing now is much more available to the rest of the industry. The work that we do in my office is much more available to the rest of the industry by virtue of the BIM software that we use, where we share a model while we're designing. When I started, which was a long time ago, right on the tail end of drafting boards, where we would set up a Mylar sheet on a board and we all had a parallel rule and ink sets, and we would sit and actually physically draw things. So I watched the transition from a drafting board to AutoCAD to now BIM and sharing a BIM model while we're designing. That's truly revolutionary. So I think that the breakdown of these barriers to information transfer, whenever you can transfer data and information from one player to the next, whether it's from Central Concrete to the design office or vice versa, or I was at a function down at Nucor Steel last week and took a tour of their plant, and we talked about a lot of these same topics, constructability and the importance of sharing information. I think it's becoming easier to do that. It's easier today than it was even a decade ago to share data, to share information in real time. So if we can get our gears to mesh instead of grinding, and if we can reduce the friction points in the handoff from one firm to the next, I think we can truly work some magic in this industry.
Cary, that's a great way to summarize it, especially as it pertains to all of us collaborating together. I think we also hear a lot on the technology provider side that, if people are adopting these technologies and they're learning from them and they're sharing that back with the rest of the industry, sometimes people feel that they might be losing some sort of competitive edge that they're getting from it. But that said, the industry needs to be able to continue pushing forward in order for people to be able to continue looking at new things that are going to give them a competitive edge. If we don't keep moving forward together and working together on those things, then we're all going to end up under the wire for that. Alana, I'm curious from your side, I know Vulcan and in the Bay Area is a big proponent of technology. And I know that you've adopted quite a lot and you can speak to whatever you'd like on that, but I'd also be really interested to hear from your side if there's data that you are really struggling to get today that would really help you in some of these discussions that you're just simply not getting or maybe not getting in the right format.
Yeah, I think one thing that has been a challenge is just getting the compressive strength breaks sometimes on projects. We're not always included in that automatically, and oftentimes we're not. And sometimes the only time we can be made aware is when the brakes are lower than expected or there's a problem. But having, all the times where those are coming in well, I think sometimes there's just no thought then to forward that to us or to share that with us. And all of that helps us to optimize mixed designs in terms of compressive strength. So that is really a value that, if we could get that more standardly, that would be a really big help in the industry, not just for ourselves, but for others too. And I think I would, echo a lot of what Cary said, and even talking more specifically on the material supply side. I've seen in my 13 years so far being here, how we have added technology that allows us to have a lot more data. And I think usually the first implementation of that is you've got to get comfortable with it, that it's reliable, and also what you know and understand and how you make decisions. Now having confidence that you can still make decisions from this and you know what this data means. So it takes some time to get to that point in learning it and being comfortable. And then I think usually kind of the first implementation of it is that you gather this data and then you go back and look at the past situations and you go, okay, now I can see this whole trail of everything that happened, or I can really look back at the situation and follow or confirm what I think happened and go back and look at it. And now I think we're at an interesting point where we've got a lot of data that now spans, 5-8 years, depending on when we implemented it. And so now how do we take that and use it for more forward thinking decisions rather than taking it and using it as a tool to say, well, what happened here? Or to look back at it. Now we're at a point where we start going, okay, how do we now take all this? How do we view trends? How do we understand it in a useful context? And then how do we take this, as you said, maybe it's data from all different sources. How do we put it in a format that we can put it together? And now we can use this to make our decisions going forward and to be even better going forward.
Right. And I really like what you said as well about the need to get confident with what you're actually seeing when you're bringing this new technology, because I think I receive that a lot as a company that's really pushing a lot of new technology all the time. People look at me and say, oh, you must be so frustrated with how slow the industry moves. You must think we're so behind and lagging. And I mean, I've been with Geotech now for just close to a decade, and it still definitely feels that way as you're having these conversations. But at the same time, I also sit here and think, well, all of the structures that are around me and that bridge that's over my head as I'm going through a tunnel here, I want to make sure that that is built with confidence. And if you have to use older technology to do it, I'd rather it, stay above my head and not crumble. And I think that's really important. There's a lot of frustration sometimes with not necessarily just the newer generation, but people that want to see a lot of improvement. But I think it's important to be reminding ourselves of what we're working with at the same time. And so that reinforcement of the confidence in the data does need to be there. But on top of that, then we have AI that's coming into the industry. And I think there's still a lot of skepticism around that. Geotech, we've been really focused on proving that AI can be practical over the last couple of years. I think we see a lot of opportunities where AI can be used, but just because AI is telling us that we can make something more efficient or optimize a mix doesn't mean that the whole industry and the other standards are going to allow us to do that. It's not just a snap of the fingers and, we have the data here and now we can use it. Where are you seeing as you're moving forward, maybe it's not just mix optimization, which is what we focus on, but where do you think AI can play a bigger role in maybe providing that confidence or simulating more models that will help us to get to some of these answers faster? Just theorize. I'm curious to hear what you think.
Yeah, I think it's going to be really interesting on the material supply side. I think there's a lot of different opportunities for it. And so when we talk about optimization or optimize, my next thought is optimize for what? Because there's all different things we can optimize for, whether it is compressive strength at, the lowest embodied carbon, but then we've got to be able to do that within the constraints of the project, specification, placement, things like that. Or are we going to optimize for, production time and servicing, a large pour that's a few thousand yards? There's different ways to optimize and what's most important on that project. And so I think with AI, I think there's potential for companies of all sizes. I think of like a smaller ready mix company that maybe doesn't have a large technical team or a large lab to be able to focus on that. I think the mix optimization might be helpful, like on a per mix basis, being able to optimize or being able to even consider new materials differently. And then I think of a company that's larger that has, dozens of plants being managed by one technical team and dozens of sources or opportunities for material sources, being able to put all of that together in a system and say, well, what is our best material selections given the types of projects that we have right now or the types of mixes that we're doing right now? You might be doing a lot of foundations mixes in one particular time period, and then it turns out to be something different. So I think handling large volume and making different decisions is a really cool opportunity that I look to AI for.
That's awesome. And Cary, what about yourself? Where do you see it playing a big role in some of these challenges?
Well, I think as we share information, whether it's through AI or just conversations like this, I think communication about common problems, common challenges is always beneficial. And so if you look at what AI is doing, is essentially scouring the world for the very best information and making it instantly available to the user. I think of, for example, I don't know if you're familiar with ACI 318, which is our building code, but ACI 318 is used around the globe, and it's a very good code, and a lot of very good people are involved writing it. But until recently, it was very difficult to get background information on a particular code provision. So you would open up the building code, typically a paper copy, until not too many years ago. You'd open up your paper copy of the code, you'd read a requirement in the code, you'd look at the commentary, which might be nothing more than just a few sentences, and that's all there was. And so you're being required to comply with this code provision. You're given a couple of sentences of background as to why it's in there. And you may or may not have a good understanding of what you're even doing and why you're doing it. Well, now we have what's called 318 Plus. 318 Plus is interactive. You can go to a code provision on your screen. You can click on icons that are adjacent to that code provision. And depending on the icon you click on, you might get a symposium, a document that comes out of some symposium. You might get a research report. You might get some data from a laboratory, but you can essentially scour while you're reading the code provision, scour all the data that was used in developing that code provision so that when you actually apply it, you have a much deeper understanding of what you're doing while you're doing it. And that's an example, I think, of where this bigger world of AI, which essentially is just sharing the world's information and making it available, is so powerful.
That's an incredible example because, you have to think that the AI that's pretty much rocked most people's worlds in their day-to-day is ChatGPT. That's the one that everybody's familiar with if they're not using it. Is it perfect by any means? No. I've referenced many times on this podcast that I have ChatGPT open on my computer pretty much all the time. And when I'm trying to think of a new idea, I'm like, well, let's just see what they say. And it's not always good, but it kind of gets me off to the right start. It helps me plan my meal plans, my packing lists, my trip itineraries. But it's not perfect, but it definitely helps. But the ability to just have these systems and tools to process all of that information and then us go in and say, I'm looking for this particular answer. I'm looking for this. And also sometimes you might find that it doesn't exist, but it's a lot easier. That dissemination of information is crucial in a world that we're in, especially with all of this happening. And then the ability for us to be able to put that all together in some sort of library that benefits the entire industry, that's huge. Like that will do huge things, especially for the newer generation coming in that want everything the way that Google gives it to them. They're going to want that. Otherwise, it's going to be hard for them to process. So I think that's massive for the industry. And we'll try to make reference to 318 Plus in the podcast episode as well so that people can find it, because I think that's fantastic. So I want to dive more into ACI because, Cary, you mentioned that, people are really working in their pods and they're working in their silos right now. And it's hard for people to prioritize constructability at a high level because people are focused on their own mandate. But there's a question of where's the accountability of trying to streamline some of these things? Who can actually take ownership for driving some of these initiatives to making us all work together? And I think ACI is doing a lot right now in terms of the board that you're a chairman of. So I'd love for you to speak more about what you're doing to tackle this issue.
Yeah, sure. Happy to do that. Well, ACI is a fabulous organization. I've been involved in ACI for over 30 years, and I've enjoyed all of it. I've served on quite a number of committees. I was president a couple of years ago. During my presidency, one of my key areas of focus was to do something about this productivity challenge that I mentioned earlier, the McKinsey report, and a lot of other reports that have been done on that topic. McKinsey is one of many. But my focus was to do something about productivity, constructability, because constructability is a big part of improving productivity. And so within ACI is a very, very large organization. I think our total membership now is approaching 40,000 members, in the high 30,000s anyway, in many countries around the world. And because we're so large, there's a lot of inertia. It's pretty hard to turn that ship quickly. And one of the criticisms ACI comes under frequently is that things take a long time to get implemented. So if you want to advance a new idea into the building code, into 318, you need to dedicate a long time, years and years and years, to actually see the change made. So on the one hand, that's good because, Sarah, to your comment about you want to make sure that when you drive under that tunnel, that thing was designed properly and it's been built properly. You don't want to make code changes willy-nilly just on a whim. You want to give them very careful thought. On the other hand, the industry is moving quickly, and one of the roadblocks to innovation and change and advancing is the difficulty of getting documents like 318 changed quickly. So what ACI did in its infinite wisdom, and it was a wise move, a very wise move, a number of years ago, we adopted a Center of Excellence program. And we have 3 of them now, 3 Centers of Excellence. The idea behind the Centers of Excellence, they're focused on one topic, and they're not encumbered by ACI bylaws and restrictions because they're separate 501c3 entities with their own board of directors, their own mission and vision, and their own area of focus. So they're under the ACI umbrella, which means they benefit from ACI's vast resources, but they're not encumbered by the need to develop consensus-based documents. So we formed 3 centers of excellence. First was NEX. The next one was NEW, which is carbon neutrality. And the third one is PRO. And that's the one that I was focused on during my presidency, was getting PRO formed. PRO's objective is to improve construction productivity. And we developed a strategic plan with 6 different initiatives, the first and foremost being constructability. We think we can move the needle on productivity by improving construction. So ACI now has these 3 centers of excellence that it oversees, but does not directly control, so that the centers can move quickly and they're focused on one narrow area. And we're quite excited. We've already rolled out a couple of deliverables to the industry. We're going to be doing a big program in Philadelphia at our next convention in November, and we'll roll out our next deliverable to the industry, which is an update of our constructability blueprint. We issued our constructability blueprint in the spring, and we're now issuing another edition of it, and that will be delivered in Philadelphia in early November.
Amazing. That's a great way to start to wrap up because we will all see each other there as well in November. But, for the listeners out there, we've touched on so many really key things. I've learned a lot from both of you today, actually. And that's why we try to reserve all of this conversation for the podcast. If I'm learning, then that means the people on the other end are hearing a lot and learning a lot as well. There's been so much to take away from this session today. But if there are listeners there that you just want them to take one main thing or one main point away or even one call to action, I'd love to just end off on that note from each of you.
Well, I'll follow on what I just talked about. I think the key message is collaboration is powerful. I think when people share information, when they develop a sufficient level of trust to allow them to share freely and willingly, they build teamwork and they truly collaborate, I think you can work magic.
Yeah, I agree with that. And I think just building off that, then the more performance-based and flexible that the specification is, the more that offers creativity between the contractor, the material supplier, also the opportunity to bring in new materials, some of the new innovative materials, and to apply technology. And then I would also say, just as sort of an action item or a thought process for anyone going forward in projects, is just looking at where can you bring value to the other participants in a project and what are their stress points, what are their challenges, and how does your role maybe help address that?
That's perfect. Well, thank you both so much. And this episode will be published before the ACI Fall Convention. So for anyone listening that's going to be there, you can find both Cary and Alana probably walking through the different sessions. Geotech will be there as well. And so looking forward to seeing you both then. And thank you so much for agreeing to be a part of this.
Yeah, very welcome.
Thank you.